Hello, everyone. In case you don't know me somehow, I am Magic. I was with PL for 7 years somehow, and yeah, through that time, wrote a bunch of IPFS, wrote a big chunk of Lotus, wrote most of Lotus Miner, and now I'm still writing Falcon things, which is Curio. Um, Curio. It's basically a complete rewrite of Lotus Miner. It shares very, very minimal amounts of code. Uh, and yeah, so this talk will cover what it is, how it's architected, how it compares to Lotus Miner, what we want to do in the future, a short demo, and yeah, there'll be question time, definitely. Overview. It's basically started as a collaboration between Lotus Miner and both teams at PL, as just a way to improve Lotus Miner, and it belonged into a completely new project. It's basically designed over the past 2 years. Basically, it started a really long time ago at this point with a lot of design iterations, and yeah, we've been building it for close to a year now. The core idea is that we built a new collaborative scheduler and put all of the state in one shared database. The database we chose is basically Postgres, and we recommend people use Yugabyte DB for that, because that it gives them high availability. And turns out putting your state in a shared database makes your life a lot easier if you want to make complex things happen. And also having a very powerful scheduler is better than the thing that is in Lotus, which is not that good. For that we get all the nice things. Like we get options of doing auto upgrades that are zero downtime. You can do kind of all the nice things you would expect in an enterprise level cluster system. Work balances nicely because the scheduler is better. It's really no scheduler. It just is nodes taking tasks, but I'll get to that. There is all of the failure recovery you would need. There is built-in alerts. There's much more built-in GC. And yeah, everything can handle any random part of the system failing. Key features, it's way simpler to deploy. I guess when we get to integrating all of Boost features into Curio, it will be way, way simpler to deploy, because Boost is like 4 binaries. Curio is a miner and a worker. Lotus Miner was a miner and a worker. Curio is just one node process you put on all the machines, and it's like, okay, this machine has those things, I'm gonna do those things. Everything is fault tolerant. Configuration is done in a very different system, so it's still like TOML, but you can layer configurations that are stored in database. So you basically set up some roles in the database, and then you just apply them to each node. So you can say this node does sealing and it has this hardware profile, and like you specify what like task limits and things it runs. Everything supports multiple miner IDs out of the box. So there's no longer need to set up like 10 different Lotus Miner instances for everything, and one pool of nodes can do work at the same time for multiple miner IDs. There's like no manual reassigning. Everything recovers itself automatically. If some task fails, it will retry a few times, and then if it really cannot figure it out, it will not entirely fail, but will give the user a notification, will say, hey, something's wrong, look at this. And then you can have an option to retry manually. yeah, there is a UI which is surprisingly nice to have. In Lotus Miner, the thought was no one's gonna look outside of the CLI, but really being able to click through your setup is kind of nice. The UI is designed to be more aggregate view for larger setups, because in larger setups, going into like hundreds of individual computers would be a bit inconvenient. But yes, we have a UI. This is how it looks like. It's like the top level view. It shows you the individual machines for now, but like, yeah, it's a UI. I will do a demo later that goes deeper. Yeah, so the other things, we have alert manager, which just sends you alerts when things happen or don't happen. Like if you don't produce posts for a while, for example, you would get an alert and know that you should look at your cluster because something is very wrong. Right now we could support PagerDuty. We probably add some more integration like emails, like probably maybe some other services, but for now this is pretty good. So yeah, what we ship right now, all of HA, you can have zero downtime, everything upgrades. It uses machines much better than Lotus. It scales much better than Lotus. Yeah, the UI as mentioned, multi-miner as mentioned, and yeah, you can also do a lot of filtering of where work happens, where do you want to put sectors, like what paths are for OSPs, what file types go where, and so on. So yeah, the going deeper. This is how the setup looks like. So you essentially have a bunch of chain nodes that you talk to. They can be Lotus or Forest, probably, we'll see. Today or tomorrow we might get this running. They can probably also be Venus if they have a compatible API. And essentially every Curio node just talks to the same set of Lotus nodes, and each Curio node will decide which nodes are healthy just by looking at their chain dipsets and seeing what should be the correct one. And so that's the chain already being highly available. Then the state is kept in a highly available database. And the database is just for metadata. There is no big data stored in there. It's just mostly work coordination and some logs, which are limited, plus configuration. So then there's a bunch of role nodes. They're not extremely specialized and can be mixed. So obviously you have the scenic nodes, which are just Curio nodes, which would pick up the work related to scenic. So like do SDR, do PC2, all the data movement can be constrained nicely if you need that. You have post nodes, which are kind of interesting because there's no post scheduler node that is explicit. Every node that does post schedules post for it, kind of the whole cluster. So as long as you have at least one post node, post will happen. Assuming that you don't have too many SPIDs, like even a single node should be able to handle window and winning post at the same time. Although you really want at least 2 GPUs in there. And obviously, the one big improvement is that for window posts, all the partitions happen independently. So you can grow your individual miner IDs to very, very, very big sizes. Like you could have 100 partitions in each deadline and it would be fine. Probably. And yeah, for winning posts, it also does it collaboratively and in a way that is safe from slashing, just thanks to having a database. So that's basically fully redundant post. Then storage. You have we can configure nodes to be more specialized in long-term storage. And so that means that you don't have to do any weird NFS setups, which are constantly broken because NFS is horrible, or you don't need to do any other network mounts. Just put Curio on your JBot head servers and it just works. And then, the Boost integration is kind of weird because the Boost architecture didn't ever expect to talk to more than one node. And Boost is just not redundant in any way. So you just need to set up like one Curio node to expose a Boost RPC server, which kind of mimics Lotus Miner. And Boost would talk to it. And for example, when you add data to, when you get a deal into Boost, Boost will call Curio, say, hey, I want to store this piece of data somewhere. And the way it works in Curio is kind of different because Curio doesn't have the at peace stage and it doesn't have any like waiting for data states. And actually, so what happens is Curio will write the deal data into a temporary file somewhere else in the sealing path that we call piece park, and it's essentially just writing the deal car file directly somewhere on the file system. And the difference is that instead of doing the unsealed sector with a ton of padding, you just store the pieces directly. And longer term, we want to make this work in long-term storage, and that will enable sharing unsealed copies between SPs. But right now it's just for Boost compatibility. And then actually the way data is ingested into sectors happens only in what Lotus Miner called PC2. Here it's 3R and 3D. You just encode data into the sector directly without like this weird unsealed staging file. It's much more efficient. This was the old slide. It's quite a bit better now. So right now, we have the full pipeline. The Snap pipeline is fully implemented, but it's still in a PR probably next week if it goes well. And sealing pipeline, I don't remember. We might actually have it now. If not, soon, because we have all the pieces for it. Post exists, is very reliable. And data ingest, we also have it working with Boost, and retrieval also works through Boost. And storage nodes obviously also there. How it works. Roughly, you set up a database. Curio will connect to it, set up the schema. Then our task engine basically means that you have nodes putting tasks into the database, then other nodes bidding for the tasks to get the right to execute the task, and then execute the task and put in the results into the database. So pretty simple task queue. It's database driven because we don't have that many tasks, and it's much easier than doing some like weird message task queues that are more generic. This simple and works very well. There's the only complex part is handling tasks which were owned by nodes, which someone like burned down or tripped over a cable or whatever. That happens and works. Task management. Essentially, the database has two core tables. It is the Harmony machines table. So each machine gets an entry there, and it will maintain it, it will ping the table entry. And if other nodes notice that the entry is missing, it will just get removed. The other important table is the Harmony task, which you just put in the tasks that are running at any given time. And basically, initially, the owner ID is null. And when a machine wants to claim the task, they set themselves as the owner. And if they succeed, which only one will succeed, because that's what you can do with a real database, the node will start executing the task. And the cool thing is, if the node dies and it's cleaned up for the Harmony machines table, because it's a real database, it's just the foreign key will clean up the owned by field, and then another node will be able to claim it. Then the way we do pipelines, like the seeding pipeline, is you have another big table where you have task IDs in there that just refer the Harmony task table, and then separate pollers on each node which look at the state of the pipeline table and just create new tasks for it. And this setup works incredibly well compared to Lotus Miner. It's also way, way, way easier to manage in every single way. Oh, this is small. Oh, well. Then this is probably even smaller. But yeah, the task flow is, like, for example, for SDR is you create a sector that, creating a sector is just adding an entry to the X sector's pipeline table, which, just has the sector number and SP ID at that point. Then one of the Curio nodes picks it up, creates the SDR task, which is then claimed by some other node. It can be the same node, but it's claimed by some node in the cluster. Oh, sorry. Then it starts the execution. After a few hours, it will be finished. That node will write to the pipeline table, hey, it's done. It will remove the task entry and just mark the pipeline entry as this sector is after SDR. And then it repeats for the SDR3 stage and so on. There's more steps, but it's actually pretty simple. It works very well. This is the new pipeline, different than Lotus Miner a bit. So there is no wait seed, there is no packing, there is no add piece. It's just you create a new sector, then you run SDR. Then after that, you run 3D, 3R, and 3C. They can happen at once. And this is different, very different from Lotus Miner. After that, you do the pre-commit message. Also, the data is encoded into sectors only in 3D and 3R. You don't need the data before. So you can actually make a pipeline where you fetch the data from the internet while doing SDR already. So you need less staging storage for deals. Yeah, and the rest is kind of similar. Just you pre-commit, you send the porep, trim, remove the unneeded data, and move sector to storage. Also, for example, the porep and commit message happen in parallel to finalize and move storage. So there's some more parallelization in the pipeline. Like, not everything is blocked on everything. It can do multiple things at once, because now it's not a fixed finite state machine. It's like just one entry in the database that says like this happens after this and so on. So yeah, Curio versus Lotus Miner. Lotus Miner is a single node. It will break and have downtime. Curio, scales way better. You can, again, kind of use it with multiple miner actors. And yeah, just more scalable in every single way. So yeah, like post can fail in Lotus Miner if you get a single process down, which will happen. In Curio, that run 2 or 3 post nodes and no downtime basically is you can achieve 0 downtime setups. Then yeah, same thing. Like if you are running with multiple miner IDs, getting sharing resources between miner IDs is extremely hard, because you need to manually reassign your workers, move around storage, and it's just tons of setup that you need to do. In Curio, it can do this with zero effort. Just say, I want to seal this many sectors for this miner ID, this many sectors for this other miner ID. It works. Yeah, scheduling. So Lotus Miner just tries to figure out what the worker resources are at any given point in time. And because it's not the same machine, it does it best, but it does a really bad job. Also, due to how storage works in Lotus Miner, it can't really know the storage situation. So it's very, very bad at scheduling based on storage. And yeah, Curio is simpler and better. It just looks for work in database, sees if it has resources for the work, and if it has storage available and resources, it just will take the work, bid for it. You can do custom, well, not yet, but soon you'll be able to do custom rules on what influences bidding for tasks. So for example, if you have two data centers and they have different energy prices, you could do bidding for work based on energy prices. Like one example. Yeah, not doable, not as minor. I think Curio is like, oh, easy. Just like put in some scripts and done. Yeah, that's what I talked about, like the additional heuristics you can add. Oh yeah, GPU handling. So Lotus Miner, it's miserable. You need to set up a worker process per GPU on your machine and then assign resources correctly. No longer a thing in Curio. You can like have a machine with 10 GPUs, one Curio process, and it will figure it out. It assigns work directly to GPUs, unlike Lotus Miner, and yeah, just works very well. Then yeah, window post. So you need less GPUs in Curio for post in general, due to basically Curio being able to share resources between miner IDs. So if you have 10 miner IDs, but the deadlines happen at a different time, you really just need one GPU for window post still. Because, like everything, like Curio will schedule partition compute, like just any other task, and then nodes with GPUs configured for post will just pick it up. So yeah, you can also share GPUs between window and winning post very easily, and that means that if you have, let's say, yeah, if you want full redundancy for post, it's enough to have maybe two GPUs, like set them up to do both window and winning post. And, if one GPU dies, you still have the other one doing both posts. And, small chance that you can miss the winning post if you're doing window post, but really unlikely. Yeah. Also not doable, Lotus Miner. Yeah, SupraSeal. We got SupraSeal running a few days ago. That means just way, way, way cheaper PowerUp. It's like 20 times cheaper PowerUp. Basically, you use as NVMEs instead of RAM. And so you don't need that much memory. And SupraSeal is also way better at utilizing cores. So basically, one core can compute SDR for 4 sectors in parallel versus the current state of things, which is you need 4 threads per one sector. So it's like 16 times better. There's big difference. I actually show this in a demo later. So yeah, the future. We want to integrate Boost into Curio, and that will mean that we get fully scalable, horizontal scalable data ingest. Because right now Boost has one process to download your data, which is not good, especially when you get to the SupraSeal world where a single machine can output really like 2.5 gigabits of replicas nonstop 24/7. Then we want super direct fetch to replica. So if you have semi-trusted clients, you can do SDR before you get their data. That means less staging storage. Also, horizontally scalable indexing would be pretty nice. Right now, Boost has one process that does it badly. And then scalable retrieval servers, like run multiple HTTP retrieval servers and get more bandwidth. Seems reasonable. Shared unsealed copies. Sharing unsealed copies is something SPs has been asking since forever, where you have a bunch of SPs collaborate and just share one unsealed copy between a bunch of SPs and just serve from it. Very longer term, but we can do it now. Snap deals with time to onboard SLA. So we can structure snap deals, mostly thanks to us getting SupraSeal in. It just gives us much more advanced level of access to the proofs. Essentially, if we structure things well, I'm pretty sure we can do snap deals in less than 1 minute to message on chain. Right? Like even 20 seconds in the most insane optimization scenario. That would be really, really cool because you basically upload data to Filecoin, it appears on chain literally 1 epoch later. Would probably be quite a big game changer, but also very hard to do. So, future. Sector markets. So, an IPOREP is going to come, and it should enable SPs to trade sectors between each other. So, if you are an SP without seeding software in one sectors, like you just have a NAS somewhere, you will be able to just order some sectors, and some SP somewhere on the internet will make them for you. You'll download them, and there will be some exchange of fill probably. So we do want to implement some markets because right now there's seemingly no other way to no decentralized way to get sectors from other SPs. And that would be pretty easy with an IPOREP. Hopefully you can get it working with interactive POREP maybe somehow, because that will be much cheaper. But yeah, this will be a pretty big game changer. Even bigger game changer if we add snark markets to it. So now you'll be able to be an SP without sealing machines and without snark machines. You just buy snarks on the internet. There are a bunch of protocols existing or like starting to exist. I'm still not sure if any of them is like Prover Network, the other one, and the other two really. I'm not sure if they will be able to support Filecoin level of proofs. Like our proofs are very big, and there's a lot of them. And IPOREP sectors will be 100 million constrained snarks, which if you tell to anyone in any other blockchain, they will say that it's ridiculous and what you're doing makes no sense. But this is Filecoin. So yeah, snark markets that work with Filecoin. We really want to make them happen, and we will in the future. Hopefully soon. Replica storage markets, much harder problem, because now you're just getting storage from people who just have storage and paying them for it. Sounds like Filecoin, but not really. This is more for, just getting storage from other people in a decentralized way. Should be solved by someone else by now, but apparently not at the scale we need, because this is like SIA just for Filecoin replicas and actually working at scale. So we might need to do it ourselves. We'll see. But yeah, it would be very nice. Like you could come into Filecoin with literally a small NAS and still provide storage without needing to be big. We'll see. Demo. So yeah, this is the Curio UI. It basically shows you the state of my cluster Yeah, you can set up the UI on any Curio node and just go in there. It shows kind of a unified view. So yeah, it shows you this, all the chain nodes, their state. It could be multiple nodes here. Right now I only have one. Shows you metrics for all the machines. This table will be nicer soon. Then you get to see pipelines for each machine. Right now I have for each SPID. So I have this SP on mainnet and 32 sectors in SDR right now. Then you have the summary of all the actors attached to the cluster. So it's like my main one. And you can see the deadlines. So, there's like a few deadlines with all the sectors proven because they're green. If they are yellow, you messed up something in the deadline. If it's red, you failed the deadline. The blue thing is the current deadline. So you can see kind of this as a deadline clock. You get to see all the wins. Then you get to see the details of the recent wins. And you can see whether the wins were included or not, which you wouldn't see in block explorers usually. And you can see all the recent wins I had are included, which is good because that means that it actually works. You can see aggregate storage use. There is storage GC, which is much better than what we have in Lotus Miner because this one works on the file level. So it just looks for files in the storage paths and it sees a file where it has zero evidence that it should be there. Like it's not a sector on chain, not a pre-commit, not unproven sector, not in any pipeline. You'll mark it for removal and then you can confirm the removal and then it will remove it. Then all the task views. So recent tasks, recent task counts, like the last 24 hours. And the view of currently running things. You can click on individual machines and see what they are doing. This is a machine that is currently working on a 32 sector batch through SupraSeal, which, you might notice that it's a 200 gigs of memory machine doing 32 sectors because it's SupraSeal. I will get to that in a second. Can view all the sector states. This is what 32 sectors looks like. All the tasks are, like I said, kind of independent. So with SupraSeal, you see that all of those entries are the same task ID. A bit small, but I guess you can see it. And that means that's essentially one machine doing work for all of those stages of the process. Then you can go into sectors and view more details. So it's a bit messy, but it looks a bit better. It looks much better when you have a real sector with real data. CC is a bit empty here. So this is that part of the UI and SupraSeal. So this is that same machine. And when you look at HTOP, right now it's a machine with 16 cores, 32 threads. And the Curio process uses 58 gigs of memory. And it's computing SDR, which will be finished in 3 hours. It's computing SDR for 32 sectors. And all of those sectors are going to be passed SDR in total 3.5 hours from start. And then for those 32 sectors, you're going to have PC2 happen on the same machine on a single 3090 in 1 hour. So 1 sector per 2 minutes. So it is in total probably 10 to 20 times cheaper than Lotus Miner, the last RESTful proofs-based mining. So pretty nuts. So Curio is stable. You can use it. We have SPs on mainnet, and if you are an SP, you can scan the QR code, go to our webpage, and sign up for free priority support if you want to upload Curio. It's free for now, and yeah, we definitely would want to guide you to use our stuff. I think it's much better, and the sooner we get people on Curio, the sooner we can stop using resources on Lotus Miner. It should be better for the network. So yeah, questions.